Chapter 5, comparing sequences to functions. So hopefully, by now we have a lot of understanding on the differences between sequences and functions, although ironically a sequence is a function. However, we'll just pretend that we're going to focus on the dissimilarities, I guess, not the similarities. I don't know. Anyways, if we look at the sequence -5, -1, 3, 7, create multiple representations, namely a graph, a table. So here we have n and t of n. We know that we have the following terms: -5, -1, 3, 7. I know if I were to graph this, the first one would be -5, the second one would be -1, the third one would be 3, the fourth one would be 7. And an equation, so we'll say t of n equals, again, if I had a zero term, it would be -9. So we'll say it's 4n minus 9. And that works because if I plug 3 in here, I get 3 out, which is what I want. Is 400 a term of the sequence? Well, I'll say no. I know because these are all odd numbers. If I keep adding an even number, they're going to remain odd numbers, so I'll never end up on an even number. So can't be. All right, now create the same things for f of x equals 4x minus 9. So we know that this will be, well, they already gave us the equation. So the table, x and y, we're going to have the same thing. 1 is -5, 2 is -1, 3 is 3, 4 is 7, etc. But when we go to the graph, it's going to look like this instead. And could 400 have an output? Yes. 400 could have an output. Again, because functions are continuous, whereas sequences are discrete. This only goes to the right? Our domain is 1, 2, 3, 4, 5, 6. There is no 0, there is no decimal. Well, in order to get 400 as an output, we need a decimal. So a function would accomplish that. So we know if we get up high enough, it's eventually going to be what it is. I don't know. So let's say 400 equals 4x minus 9. We get 409 equals 4x, we divide by 4, so x equals 102.25. So if you input 102.25 into here, you'll get an output of 409. The thing is, you're not allowed to input 102.25 into here because it could go 102 and 103, but not 102.25. One of the differences between a sequence and a function. Same thing with 5, 1, 15. Let us consider the difference between t of n equals 2 times 3 to the n and f of x equals 2 times 3 to the x. Is this a function? Yes, it's a function. Is this a function? Yes, it's a function. Why or why not? One input is one output. But again, this implies it's a function that is continuous. This implies it is a sequence that is discrete. So we have that subtle difference. But they are both functions because they both have one output for one input. Is it possible for t of n to equal 1400? So I don't know. We're going to say 2, and then it just triples, right? So 2, 6, 18, 54. So we'll just start multiplying by 3. So 54, oh my God, I keep doing that. 54 times 3 times 3 times 3. And we're just seeing if we land on 1400. And of course we didn't. So we would say no, this one couldn't, t of n couldn't equal 1400 because it skips it. Could this one? Yeah, this one could. Again, because it's continuous, so we can plug in whatever we need to get it to pop out 1400. So how are functions and sequences similar? They're similar in that they're both functions. They both have inputs, outputs. The equations are essentially the same. They're different in that sequences are discrete and functions are continuous. And sequences have a domain that is restricted to 1, 2, 3, 4, 5. Again, the counting numbers. Whereas a function can be negatives, zeros, decimals. A sequence can't be. So you can go ahead and fill in that learning log if you want. 5.1.17, read the math notes. It just is a kind of review of everything. And we've seen that a to the n a little bit already. It doesn't really mean much. It's just a different notation for everything else that we've already been doing. So for a, we're going to come up with the first 5 terms. Well, we know that the 0 term is -1. And then from there, our sequence will look like this. What are the first 5 terms? Well, we're going to add 1.5 each time. So I'm going to get 0.5, 2, 3.5, 4.5, 5, 6.5. We're just adding 1.5 each time. If you're not sure, feel free to plug in like 4. If I plug 4 into this equation, I get 6 minus 1, which is 5. So that works out well. Now here, what are the first 3 terms of this sequence? And again, we know we're going to multiply by -8. We know that the 0 term is 1/4. So what if I multiply 1/4 by -8? Well, because of cross canceling, I'm going to get -2. -2 times -8 is 16. 16 times -8, that's a good question. 16 times -8, we know it's going to be -128. So those would be the first 3 terms of this sequence. Write an equation for the sequence of this. Well, it's multiplying by -1, right? But the 0 term would be +4. So we'll say T of n equals, my 0 term is 4, and my multiplier is -1 to the n. So there we go. We have an equation for this. And write an equation for this one. Well, again, this is arithmetic, so my 0 term would be 1. So I'll say T of n equals, it looks like I'm adding 6 each time, and my 0 term is 1. So just a review of this stuff. If you haven't actually learned this section yet, then you're probably not sure how I got through these so quickly. But if you have a pretty good understanding of what's going on, you should be fine. All right, let's go ahead and finish this bad boy off. So Janine was working on her homework but lost part of it. She knows that at one point P of r equals 2 times 5 to the r is 78,000, but she's not sure if it's a sequence, a function, or both. So let's go ahead and plug this into the calculator and let's see what we come up with. So we're going to get 2 times 5 to the x, and again, interchangeable letters and stuff, right? I'm just going to x and y instead of r and P of r. We go ahead and we look at the table here. At least for once I didn't look at the graph. And we're looking to see if this lands on 78,000. So you can see I'm already way too far down in the table, so I'm going to move up. So we'll see if I can get 78,000. And you can see it definitely misses 78,000. So it can't be a sequence, but it absolutely can be a function. It's not going to be both. Again, just the fact that it's discrete, it just skips 78,000. Discuss with your team how you can use your graphing calculator to solve each of the following equations for x. Calculate to the nearest 0.01. So again, you're going to learn actually how to solve these things for real your junior year. They're called logarithms. They're pretty cool. But we don't really know that yet, so we're just going to go ahead and plug our equations in to the calculator and look at the table and see when it ends to be pretty close to 3.125. So let's see when we get close to 3.125, and you can see we get exactly at 6. So this one would be 6. And again, on this one, we're going to plug in 6 times 3 to the x, and we're going to look at the table, and we're looking to see when we get 318, and we don't get 318, we get 3 point something something. So we don't know exactly what, but 3 point something something will get us as close as we can get to that. So that wraps up to chapter 5. Obviously there's some worksheets and stuff that go with this chapter that I would encourage you to be doing as well. Have a good one.